Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 8, unit number 8, functions and graphs. In previous video lecture, we discussed the exercise question number 1 and question number 2 of exercise 8.1. In this video lecture, we will discuss the coming questions of the exercise 8.1. So we start from question number 3. Find all values of x. So we need to calculate the values of x, all real values of x, such that f of x equal to 0. So this condition is given that when the given function equate to 0, then you need to calculate the values of x, but those values must be real. So part number 1 is f of x is equal to 15x minus 3. We need to calculate the value of x when f of x is equal to 0. So we need to calculate, find the values of x which must be real values when f of x is equal to 0. But in the question you see that f of x is equal to 15x minus 3. So therefore this implies that 15x minus 3 equal to 0. You clearly see that because the function is equal to 15x minus 3, so that's why you will put 15x minus 3 equal to 0. Now taking common 3, so this will be 5x minus 1 equal to 0. Dividing both sides by 3, you will get 5x minus 1 equal to 0, because when divide 3 on the left hand side, so 3 will cancel with this 3, and when you divide 3 on the right hand side, so 0 divided by 3, you will get 0. So this implies that 5x is equal to 1. Dividing both sides by, shift this minus 1 on the right, so that will become plus 1. Dividing both sides by 5, so that will be equal to 1 divided by 5. So this is the value of the x. This is your answer. Now you get a single value of x, because when you equate the given function equal to 0, so you get a linear equation. You see that this is a linear equation, and the degree of the linear equation is 1. So according to fundamental theorem of algebra, the number of the the number of the values of the unknowns will be equal to the degree of the given equation. So the degree is 1, so that's why you will get one solution. So this is part number 1. Now for part number 2, I'm now solving part 2. So for part 2, you clearly see that f of x is equal to x cube minus x, and you need to calculate the values of x when f of x equal to 0. So for the required values of x equate f of x to 0, that is x cube minus x equal to 0. f of x equal to 0, so f of x is equal to x cube minus x equal, so that's why this is equal to 0. Now taking common x, so this will be x square minus 1 equal to 0. Now you know that when the product of the two factors equal to 0, so at least one of them must be 0. So from this equation we can write either x equal to 0 or x square minus 1 equal to 0. So this is the one value of x. Now this is x square minus 1 square. You can write 1 as 1 square, because 1 square is equal to 1. So a square minus b square. So a plus b, a minus b equal to 0. So you see that here in this equality, you clearly, in this equation, you clearly see that on the right side the two factors equal to 0. So when the two factors when the two expressions become equal to 0, so it means that either one of them at least must be 0. So either x plus 1 equal to 0 or x minus 1 equal to 0. So this implies that x is equal to minus 1, and this implies that x is equal to plus 1. So you see that the values of x are 0, 1 and minus 1. So these are the required values. You get three values of x because when you equate the given function equal to 0, so you will get a cubic equation. You clearly see that this is a cubic equation. So its degree is 3. So that's why according to fundamental theorem of algebra, you will get 3 roots, 3 solutions of variable x, 3 solutions. So you clearly see it. Now moving towards the another part, which is part number 2. This is part number 3. Sorry, this is part number 3. Now moving towards the part number 2. This is part 3. Sorry. Okay, part 2. In part 2, you see that the given function is equal to x square minus 8x plus 15. So for the values of x, we equate the given function equal to 0. This is mentioned in the question. So this implies that in place of f of x, you will write x square minus 8x plus 15 equal to 0. So this is a quadratic equation. So you will get two values of x because this is a quadratic equation. Now how you can solve this quadratic equation? You can solve quadratic equation by factorization, by completing square formula, and by quadratic formula. So I am using the completing square. So the coefficient of the x square is multiplied with the constant term, so you will get 15. Then you need to split this minus 8 in such two numbers that from addition of those numbers you get minus 8, and from the multiplication you get 15. So if I split minus 8 into two numbers, and the two numbers are minus 3 and minus 5, so when you multiply minus 3 and minus 5, you will get 15, which is equal to the product of the coefficient of x square and constant term. And when you add those two numbers, which are actually you split minus 8, so that are minus 5 minus 3, so you will get minus 8 from the addition. So that is the perfect splitting of minus 8 for the required solutions. So this is 5x minus 3x plus 15 equal to 0. So this implies that I am taking common x from these two terms. So this is x minus 5, taking common minus 3 from the remaining two terms. So this is x minus 5 equal to 0. X minus 5 is again common. So I am taking x minus 5 again common, and x is remain here and minus 3 is here. So you see that the product of the two factors equal to 0. So either at least one of them must be 0. So either x minus 5 equal to 0 or x minus 3 equal to 0. So this implies that x is equal to 5, and this implies that x is equal to 3. So the required values of x are 3 and 5. So you see that you get two values of x because the given equation is quadratic when you equate the given function equal to 0. Now switching towards part number 4. You see that this is your part number 4. So in part number 4, you see, now part number 4, f of x is equal to x cube minus x square minus 5x plus 5. So equate this f of x equal to 0 for the values of x. So I am doing it direct. equate this function equal to 0. This is mentioned in the question I detailed in the previous 3. So this will become, the given function will become x cube minus x square minus 5x plus 5 equal to 0. So this is the cubic equation. So you will get 3 values of x, 3 real values of x. Okay, I am taking common x square from the first 2 terms. Now if I combine this x cube term with minus 5x, so that will be x cube minus 5x, and this minus x square is written with plus 5 equal to 0. So taking common x from these 2 terms, so that will be remain x square minus 5, and taking minus 1 common from this, so that will be x square minus 5 equal to 0. You clearly see it. Now x minus 5 is common, and x minus 1, here you will remain x, and here the remaining number is minus 1 equal to 0. So you see that the product of two things equal to 0, so it means that at least one of them is equal to 0. So either x minus 5 equal to 0 or x minus 1 equal to 0. So from here you will get x is equal to 1, and when you shift this 5 on the right, so that will become plus 5, taking square root on both sides, so x is equal to plus minus 5. So the required values of x are 1, plus 5 and minus 5. So 3 values, because the equation, when you equate the given function equal to 0, so you will get a cubic equation. So that's why you will get 3 values. So this is the question number 3 of exercise 8.1. Now moving towards the question number 4. In question number 4, you need to find out the domain and range of the given function. Question number 4. Find the domain and range of the function f of x. In part number 1, the given function is quadratic function. F of x is equal to 5x square plus 2x minus 1. So you see that this is the quadratic function. So we know from the theory, from the previous videos, that the domain of the quadratic function is the set of real numbers, because when you replace this argument x in this expression, you will always get a defined value. So according to the definition of the domain, you know that domain are those values of argument, domain are those values of the independent variable, domain are those values of input for which the given function is defined. So if you put any real number from the set of real numbers, this function is defined on those values. If I put 1, so that will become 5 minus 2 minus 1, so you will get 2, defined value. If I put 0, so you will get minus 1, defined. If you put every real number and plug that real number in place of the argument x, you will get a defined value. Mean function is defined for this all real numbers. So domain is the set of real number R. So this is your, you can write this explanation, or in short you can just write the given function gives a defined value for all real numbers. Therefore, domain of f means this function, equal to set of real number R. This is your domain. All the real numbers gives a defined value when you plug that in this function, and when this function operate on that real number, you will get a defined value. So this is the domain. And in range you will also get real numbers, because you are plugging real numbers, and when the real numbers calculated in the put in this expression and you calculate, you will also get a real number in the range. So also range of the given function, quadratic function, is set of real number R. So the domain of this function is also set of real number R, and the range of this function is also set of real number R. Okay, now moving towards the part number 2, a most important part in this exercise. You need to calculate the domain and range of this function. This is the most important part in this exercise. If you see to the given function, this is the square root function, and I already explained that here we are discussed a course which comes under the umbrella of real analysis. So real analysis is such a subject of mathematics in which we only consider set of real number as the largest set. We didn't bother to take complex numbers in the study, so we avoid complex numbers. So this is a square root function. So now you will check that on which values this square root function is positive. If I put 3 here, so 9 minus 16, so that will in square root you will get minus 7. So it means that on 3 this function is not defined. When I put 3, this is just an example, so this will be 9, 3 square 9 minus 16, so you will get minus 7. So this is a complex number because square root of minus 1 is iota, so we didn't consider complex number in case when we are studying the function comes in the calculus course. So in calculus we consider the set of real number is the largest set. So that's why you need such values on which you get a defined value, so that will be your domain. So in this case you need to exclude from the set of real number those values on which this square root function gives a negative value. So you see, whenever I plug a value from this open interval, this is your open interval, small bracket minus 4 comma 4 small bracket, this is an open interval. This open interval contain all the values between minus 4 and 4. If I draw it on the real line, so this is 0, so this is minus 4 and this is 4. So this minus 4 and 4 is not included in this interval. So you see that this is the open interval. If I choose any value which is greater than minus 4 and less than plus 4 and put in this square root function, you will get a negative. There will be iota. Iota will be a fair. So for those values the function is not defined because we are discussing real analysis. So we will see for the domain values which must be real, the output must be real. So on 3 you see that the output is 7 iota, so this is not real. So it means that on 3 this function is not defined. Although you will not confuse yourself by seeing that this is a number. Okay, this is a number, but in case when you are studying function, so you will only see to the set of real number is the largest set. You didn't know, in other words you can say you forget the complex number. You need to forget the complex number. So the domain of f is all real numbers except you need to subtract the set which contain the real numbers between -4 and 4. So this is your domain. This is an important part. Sorry for interruption. Okay, so this is the domain. Now what will be the range of this function? When you putting values from the set of real numbers excluding these values, so all values which is not present in this interval, and that this square root function must be positive. When I put 5, so 25 minus 16, so you will get 9, so 9 square root is equal to 3, positive. If I put -5, so on that you will also get +3. So you see that when you plug values in this function other than this interval, so you will get always a positive values in the range. You can also put +4 and -4, because in this interval +4 and -4 is not included. This is open interval. So when I put +4 or -4, so you will get 16 minus 16, 0. So the minimum value in this outputs in the range will be 0, and so on. So this is a half open, half closed. From this side this is closed, means 0 is included, and after 0 all the real numbers up to infinity is included. So non-negative real numbers. In other words, you can say that this is the notation for the non-negative numbers. Non-negative real numbers. So this is the range of this function. This is an important part. You must understand these two, how you can calculate the domain and how you can calculate the range. Okay, so this is question number 4 of exercise 8.1. Inshallah, in next video lecture we will discuss the remaining question of exercise 8.1. Thank you.